All right, welcome to 8.7 Base E and Natural Logs. So in our last set of notes, we talked about the common log. And the common log we said is base 10, but it's written as log of x. Okay, so we said that we assume if we see log of x and there's no base written, we assume it's base 10. Just like when we see a radical with no index number, we assume it's a square root. Now, with logs, there is another kind of log that we assume people know what the base is. Okay, so this, we're going to use base E. So E is one of those numbers in math, just like pi, 3.14, and E is equal to 2.71828. And it goes on and on and on and on, just like pi. So E is called the natural base. So when we use E with logs, we call it the natural base. And then when we use it as a base, we don't write log base E of x. We don't write it like this. We actually just call it the natural log. So it's written like this. ln of x. Okay, so now we've got a new log with a base that we should know. Ln of x is just log base E. Now, E was discovered by Jacob Bernoulli and he discovered it when he was trying to calculate a limit, which is something you will talk more about if you get to a calculus class. So he was trying to calculate, let's just look real quick, the limit as n approaches infinity of 1 plus 1 over n to the nth power. So as he was trying to calculate this, okay, he discovered E, which is a number just like pi, okay, and it's 2.71828. So some of these odd trivia that we're going to talk about in the next few days, it might be a good idea to remember some of them for just as extras for the test. Wink, wink. All right, so we've got a new log base E, or the natural log. So what we're going to do, we're going to just jump right into an example. So we'll call this example 1. And example 1 says write in logarithmic form. Okay, so we're going to practice changing forms. We're going to practice condensing logs. And then we're going to practice some solving. So write in logarithmic form. And in example A, here we go. We're going to start off with an exponential. So we've got e to the x is equal to 8. Now, don't let the e throw you off. It's just like what we've already done. Okay, this is an exponential. We've got a number raised to an exponent equal to an answer. So what we're going to do, we're going to go through and label. We have a base raised to an exponent equal to an answer. And when we change this into log form, we're going to say log, and then we're going to change our letters to be B-A-E. So if I rewrite my letters as B-A-E, B, A, and E. Now, the only thing that's wrong with this is that we never ever write log base E. Log base E is called the natural log. So when we write this and we change forms, we're going to just say ln of 8 is equal to x, because the ln means log base E. Okay, let's do another one. This is example B. We are given e to the 5th power is equal to x. Okay, same idea. This is an exponential. So in exponential form, we have a base raised to an exponent equal to an answer. And when I switch forms, I'm going to write log base b, but the base is e, so really I'm writing the natural log because it's log base e, and then the a, and then e, because I want to spell out bae, B-A-E. Okay, but log base e is the natural log. Okay, now let's work backwards. So we'll call this example 2. Example 2 says write in exponential form. And then here in problem A, we are given the natural log of x is approximately 0.7741. And we need to change forms into exponential form. So ln is really log base what? ln is log base what? E. So when I'm looking at this, I'm thinking, okay, logs are still BAE, but the B we're just going to write over here, and we remember ln is log base E, and then A, and then E. So then when I change forms, I have a base. What did we just say the base was? E. Base is E, raised to an exponent, 0.7741, equal to some answer. Okay, let's do another one. The next one, we are told that the natural log of 10 is equal to x. So the natural log is still a log, so I'm still thinking that silly trick, logs are BAE. Okay, BAE. Except that I know the base is what? What's the base for ln? It's E. So the base for natural log is E. So I know I have a base raised to an exponent equal to an answer. Okay, so this is the same as we've always done, but it's also different because we have to remember natural log is base e. Okay, the natural log is base e. Now, the natural log is still a log, so all of those log properties on the whiteboard still apply to the natural log. So what we're going to do, we're going to take a look and we're going to use some of those log properties to condense some expressions. So we'll call this example 3. And example 3 says write as a single logarithm. So here in problem A, we are given 3 times the natural log of 10 minus the natural log of 8. And we're using the same log properties that are up on the whiteboard that we've been using since 8.5. Now, before I can condense this, so right off the bat, it looks like there's 2 logs getting subtracted. So I know I'm going to use property 2, but how do I deal with that 3 out front first? What can I do with that 3 out front? Show me which log property says I can move the coefficient. So show me on your hand which log property says I can move that coefficient. Very good. A few of us have got it. Log property 3 says if we have a coefficient, we could move it back as an exponent. So we first need to move all of our coefficients back. So this is really 10 to the 3rd power. Okay, so this was property 3. So we can move that back. Now I've got 2 logs being subtracted. Which log property tells me how to combine these? 2 logs that are being subtracted. How do I combine these? Which log property is it? 1, 2, 3, 4, or 5? Very good. Log property 2 says if I have 2 logs being subtracted, I'm going to go ahead and divide the arguments. So this is really the natural log of 10 cubed. 10 cubed is 1,000 over 8. So this was property 2. And then let's go ahead, since we have a calculator, divide 1,000 by 8. And what do we come up with? 125. Very good. So now we've condensed this and written it as 1 log. All right, let's try another one. We'll call this example B over on the right. In example B, we are given the natural log of 40 plus 2 times the natural log of 1/2 plus the natural log of x. All right, so I've got 3 logs being added. Seems like I'm going to use property 1, but before I can do that, what do I have to take care of? The 2 out front. Very good. So the first thing I've got to do is take care of this 2 out front. How do I take care of the 2? Which log property tells me how to take care of it? Show me on your hand. Which log property tells me I can move the 2 out front? Very good. Log property 3 says, hey, just bring it back as a coefficient. So this is the natural log of 40 plus the natural log of 1/2 squared plus the natural log of x. Now, I've got 3 logs being added. What am I wanting to do with the arguments? I'm using property 1. Property 1 says do what with the arguments? Multiply them. So let's go ahead and throw them all together. This is the natural log of 40 times, what is 1/2 times 1/2? 1/4 times x. And we can just throw them all together all at once. Okay, so 1/4 of 40 is 10. And then we've got x. So we started by using property 3 and then property 1. Okay, let's do another one. We'll call this example C. In example C, we've got 6 times the natural log of 8 minus 2 times the natural log of 4. Which property do I need to start with? Show me on your hand, which property do I need to start with? Very good. We got to start with property 3. Before we can use properties 1 or 2, before we can add or subtract logs, we have to move all coefficients. So we're going to start with property 3 to move all of those coefficients. So I'm going to move the 6 back as an exponent, and I'm going to move the 2 back as an exponent as well. So this is really the natural log of 8 to the 6th power minus the natural log of 4 to the 2nd power. Now, all the coefficients are gone. I've got 2 logs that are getting subtracted. Which log property am I going to use? Property 2, very good, says that I should take my arguments and divide them. So this is really 8 to the 6th power over 4 squared. Let's grab our calculator. Somebody type in 8 to the 6th power. So I'm going to do turn on. We're going to hit the 8 button. Caret 6. Remember, the caret button is this. Looks like a triangle without a bottom. That gives us an exponent. So we can type in 8 caret 6. We should get a really long number. 2621444. I already know 4 squared is 16. And when I divide them, I've got 16384. Anybody else get that as well? So give me a head nod. Do we get this as well? We need to practice. Good. Okay, now we're going to take a look at solving some problems when we have natural logs and e. So now we're going to take a look and we're going to solve some problems. The nice thing about natural logs is that they're still logs. They still follow all of the same properties. They just have a different base. So let's come back over to the left side of our page. We'll call this example 4. So this is example 4. And example 4 says to solve. So in example 4, we're going to look at solving exponential equations. In example 5, we're going to look at solving logarithmic equations with base e. So we're going to do the exponentials first, and then we're going to do the logs. Okay, so here in example A, we are given 4e to the power of negative 2x minus 5 is equal to 3. Now, the first thing to do is not to panic. This looks a little more complicated only because it has 2 variables. But e is just a base. It's a number. So the first thing we want to do, we're trying to solve for x. So let's just think through this. I'm trying to solve for x. X is currently trapped in the exponent. So what I want to do is I want to get e to the negative 2x all by itself. So the first thing I want to do is I want to get e to the negative 2x all by itself. So if I'm trying to isolate that piece, the first thing I need to do is move over the 5. If I move over the 5, I've got 4e to the negative 2x is equal to 8. My x is still trapped in the exponent, so I'm trying to isolate that piece. Right now, there's a 4 hooked on there. How do we get rid of the 4 that's hooked on there? We add the 4, subtract the 4, multiply the 4, divide the 4. We're going to divide the 4 because it's being multiplied to e. So the opposite of multiplication is division. Now I've got e to the negative 2x. I've isolated it. The x is still trapped, but it's isolated. Once it's isolated, what we're going to do is we need to untrap the x. So let's think about our log properties. I want to untrap the x. So I'm going to do something with a log to get it out of there. So what we're going to do is we are going to use log property 4. So everybody take a look up at the whiteboard. Log property 4 says if we have a log with a certain base and we plug in an exponential that has the same base, all we're left with is the exponent. So on our problem, we have an exponential with the base of e. So if I wanted to use property 4, I would need to take a log with the base e. So what I'm going to do is take the natural log of both sides. So this is property 4. If I take the natural log of e, natural log and e get rid of each other. And I'm left with negative 2x is equal to the natural log of 2. So property 4 says the natural log of e, those two things get rid of each other. So I've got negative 2x is equal to the natural log of 2. How do I get x by itself? Divide by negative 2. Okay, so what we're going to do, we're going to practice in our calculator. So grab your calculator, the one you're going to use for the test. Right under the log button on the calculator is a button that says ln. Click ln, that's the natural log of 2. enter, then you're going to hit divided by -2. And when you type in the negative, you need to use the negative that's down by the equal sign. So that little negative that's in parentheses. Do not use a minus sign. If you use a minus sign, it will give you an error code. Okay, so we're typing in the natural log of 2, enter, divided by -2, enter. And this is what we should come up with. This is our practice for the test so that when the test gets here, you know how to put this in the calculator. So if you're having trouble, raise your hand and I'll come help you. Okay, let's try another one. We're going to do another exponential. We'll call this example B. In example B, we're given 15 is equal to 3e to the 4k minus 12. So this is an exponential equation that we're trying to solve. The variable k is trapped in the exponent. So e to the 4k, I want to isolate e to the 4k. So let's go ahead and isolate it. So we're going to add 12 to both sides. So this is 27 is equal to 3 e to the 4k. If I'm trying to get e to the 4k by itself, I need to take the 3 and divide it out of there. So we're going to divide the 3 to the other side. So I've got 9 is equal to e to the power of 4k. How do I get rid of e? I'm going to take the what of both sides? The what? The natural log. Good. Because 9, let's think about this. 9 is a base and e is a base. Can 9 and e break into the same thing? No, so what we want to do is we just want to get rid of the e. So we're going to take the natural log of both sides. The reason why is property 4 says natural log and e are going to get rid of each other. So I'm left with the natural log of 9 is equal to 4k. And if I want to get the k by itself, we're going to divide both sides by 4. So I've got k is the natural log of 9 over 4. And we're going to throw that into our calculator, and everybody needs to practice. So type in the natural log of 9 divided by 4. Are there any questions? Okay, we're going to do 2 more. So one more type of problem, but we're going to do 2 examples. So we'll call this example 5. Example 5 still says to solve. In example 5, we're given 3 times the natural log of 4x is equal to 24. Now, on these problems, the easiest way to kind of logic through and think about what we're doing is just to think, okay, so the x, the variable, is trapped inside the argument. So if I want to untrap untrap our variable, we're going to need to get that log by itself. So the first thing we want to do is we want to move the 3. Now, in this case, moving the 3, we're just going to divide both sides by 3. So I've got the natural log of 4x is equal to 8. The x is still trapped. Does anybody have an idea? How could I untrap the x? How could I get rid of the log part? I'm not going to use one of the properties, but maybe I should. Can't divide it. So how can I move away from the log and into something else? Any ideas? Maybe switch forms? Okay, so let's go ahead and switch forms. So I'm thinking, okay, logs are B, A, E. What's the base on a natural log? E. So I know I have a base raised to an exponent equal to an answer. All right, so is the x trapped anymore? No, x is not trapped. It's still not by itself, but it's not trapped. So let's divide both sides by 4. And we've got e to the 8th over 4. So grab your calculator. Here's how we're going to do this. So we're going to hit, to get the button E, here's how we do this. We're going to hit the blue second key. So that blue second key, what it does is it gives us access to all the blue stuff written in between the buttons. So we want all the blue stuff written in between the buttons, so we're hitting the second key, and then we're going to hit we're going to hit the LN button, because right above it written in blue is e to the x. So that will give us e. So we're going to hit second and then the natural log button. So then we have e caret parentheses what pops up on our screen. So we're going to type in 8, enter, and then we're going to divide it by 4, enter. So we should get a kind of a big number, 745.2395. So you're hitting, so let's go through this again. You're hitting second, then natural log button, then 8, enter, and then divide by 4, enter. All right, let's do another one. This will be our last problem for this set of notes. We'll call this example B. We're given the natural log of x minus 8 to the 4th power is equal to 4. All right. So, same thing. The x is trapped in the natural log. So, what I want to do is I want to change forms. However, before we change forms, what we need to do is we actually need to get that exponent out of there. We got to move the exponent before we can change forms. Because the exponent, we need to move it. So, if I want to move this exponent, I'm going to bring it down out front. Then I'm going to divide both sides by 4 to get rid of it. Now, how do I untrap the x? Just like the last problem, how do we untrap x? It's trapped in the argument. Yeah, we're going to switch forms again. So I know anytime I see a log, I think logs are b, a, e. That silly trick to help us remember. What's the base of natural log? E. So I have a base raised to an exponent equal to an answer. The x is not trapped anymore. So now I can try to get x by itself. So we're going to add 8 to both sides. So e plus 8. Here's how we're going to put this in the calculator. We're going to hit the second button. Then we're going to hit the natural log button because the second button gives us access to the blue right in between the keys. And then we're going to type in 1, so get e to the first power, which is 2.71828, and then plus 8. Oops. So this should be 10.7183. And that's it. All right, this is all I have for you for the 8.7 notes. As always, if you have a question, feel free to watch this video again or send me an email.